Hey, thanks for coming. We're going to be talking about best practices for AAA development in Unreal Editor for Fortnite. So hello, I'm Derek Diaz. I've been doing UX UI work for Fortnite at Epic for over 10 years. I love not just making games, but also making tools for creators.
Hi, I'm Jay Villanueva. I'm a technical product design director. I joined Epic at 3 years ago to help launch UEFN. I've made games for over 21 years. I've shipped games both large and small. And I play all your games because my job at Epic is to ensure that UEFN can make games and that we respond to your feedback and that making those games is as fun as we can make it.
All right, thanks, Jay. We're going to start by talking about ways to make high-quality widget-based UI in UEFN. And after that, I'm going to share some examples to demonstrate these techniques. And then Jay will talk about some best practices. All right, to start off, UEFN. This is Epic's freely available tool for building and publishing games in the Fortnite ecosystem. So many incredible worlds have been made by creators. In 2024, 5.2 billion hours of play was spent on creator-made games. So Epic has also shared some visually striking demos. You can see some here. I really love the diversity in these here. Now, an important part of any interactive experience is, of course, the user interface. That's my world. It's my favorite part of it. And as you can see here, there's not a whole lot of UI. Today, I'm going to demonstrate how to make compelling UI to accompany awesome worlds like these. And in the end, we'll revisit some with sort of fresh new UI. All right, the techniques I'm going to cover focus on three main parts. The first part is gameplay data, using it to drive your UI. The data will come from devices, and you can see some here on the right. There's about 10 of them that work this way right now. We're going to focus on a really useful one called the HUD controller for a lot of this presentation. That's the one I'm pointing to over there. All right, the next part is using UMG to drive your UI with that data. A pretty cool example is shown here on the right. As you can see, that kind of health widget looks nothing like something in Fortnite. There's a lot of great tutorials on making UI widgets. So I'm not going to focus on how to use the tool to do that right now. You can find good examples on Epic's documentation's website. That's the QR code that's linked there. And by the way, we'll have that during the Q&A session on screen, so you don't need to worry about it right now too much. You can also search for awesome tutorials made by our creators. The third part involves using UI materials like the one shown here. So UI materials can be made in such a way that parameters are exposed that let you change how they look. So in this example here, you can change that image in the middle, you can change the size of it, the position, the shape, the colors, and more. And they can really step up the UI in your project. So there's a lot to learn in each of these three areas. I'll cover the broad strokes mainly, just to demonstrate a workflow that uses those three pieces in the tools. All right, so one of the biggest benefits of this technique is that you don't have to write code to control your UI behavior. So for example, you don't need to hide your UI before showing the inventory screen and then show your UI when the inventory screen closes. That's all automatic. Also, there's a lot of examples you can follow, making it a great intro into UEFN. And of course, you can always do a lot more by adding your own custom code. All right, let's start with the UMG editor. So this is our UI design tool. I thought a great way to start is to actually see the gameplay data in action. So to do this, I've made a really simple widget just to show sort of this raw data. All right, on the left, we have our gameplay data in the form of a view model. I'll show you how I added it in a moment, but seeing it here is great because it shows you all the data that you have to work with in your UI widget here. In this case, our view model contains data of all different types, such as text, and numbers, and Boolean logic, textures, and material art. This particular data set's called player information. It gives your UI access to things like health and shields, player art, name, and more. View models update whenever the data changes, such as when your player takes damage or gets knocked down or gets disconnected. The cool part is that you can use this data in lots of different ways. It's totally up to you. In the middle here, we have our UI widget. This is one I made quickly. It's just a stack of text blocks with an image at the top. We're going to use that to show the player portrait. Our goal here, again, is just to put all the data on the screen in raw form so we can see how data changes during gameplay. On the right, now we have our data bindings. This is the glue between the data on the left and the UI in the middle. All right, to see it in action, we simply add a HUD controller device to the world. You do this by dragging it from the content browser straight into the world. Let me hit maybe play again. All right, so zooming into it a bit more over here, the HUD controller provides data to the assigned UI widget. In this case, it'll replace the default vitality widget. So just as a reminder, this is what the default vitality widget looks like in a UEFN project. So then we assign that UI widget that we just made to a UI override property on the HUD controller device. And it's that device that makes that view model data available to the UI widget. All right, now we can see our very boring UI in action. As a player is hit, you can see shields and health values change. Look carefully and you'll see the states change, such as is being revived and is eliminated. Let me look over here. And he'll get shot again and you'll see is eliminated change to a 1. So you can do all kinds of interesting things by making custom widgets to use this data. All right, here's how you add a view model to UMG. That's the design tool, the UI design tool. As you can see here, there are quite a few options, and we're going to take a closer look at some of that data right now. All right, so this is the player information view model. This is all the data that it has. It's organized into 3 parts. The first part has player art, player name, and their slot number. That's basically player identity information. The second part contains useful state information, like I just mentioned. This allows you to change the UI when the player is knocked down or revived or even disconnected. The third part has vitality data like health and shields and more. There's actually quite a lot of data packed in there. There's the raw form of health and shields. There is also normalized data, which gives you a value between 0 and 1, which is useful. We'll look at that in a minute. There's also delta information that tell you about changes in that data. And you can use all this to dynamically update your widget. Another awesome view model is called equipped item. So it follows a similar pattern. As you can see, this one provides art for the item the player is carrying and data about item states, ammo counts, and so on. All right, this technique is exactly how we built part of the HUD for Ballistic, which is a tactical shooter game released at the end of last year. It's actually a simple setup. So here's a shot of the HUD from Ballistic. And we're going to focus down here. You can see the player vitals, health and shields on the left, and the weapon info on the right. And looking closer at the actual widgets, you can see they're pretty clean, simple widgets. On the left, we have our custom vitality widget using the player info view model. On the right, we have a custom widget using the equipped item view model. Okay, so next I'm going to get into binding UI to the data. Let's jump in. Here again is that UMG widget from Ballistic for the player's vitality. Let's focus on the panel on the right. This is where you connect your UI to the data from the view model. Here's a simple example that sets the player's name to a text block in the UI, right? You first select your UI element on the left. Here we're picking the text property of a text block meant to show the player's name. And to the right, you select data from the view model. So we're picking the player name data. So data is assigned from right to left. So this is a really straightforward example. You can do more than just set text. And here's some more examples. You can convert numbers to text that you can display. So you can show your health and ammo count as text if you want. And that's what we did in Ballistic. You can also control the visibility of UI based on Boolean states, such as is being revived and is connected. So you can use this to say, show a special icon on the HUD when the player is knocked down, and down but not out, as we call it. They're also really useful for handling things like player disconnected. You can even move your UI elements by using transforms driven by data. A really useful binding is to use a UMG widget switcher to show UI based on, for example, what slot the player's in. Right, so here, when the player slot is equal to 0, it's going to show this big card, player portrait and health and shields. And if the player slot is equal to 1, it's going to show this small card, for example. Images are also supported. On the top, we are showing the player portrait by binding an image's brush property to the texture data in the view model. So this approach lets you pass the texture or material to an image widget. You can even set the size of the image over here, or you can just leave it alone and it'll follow the default size of the image widget. Now, this is where the real magic happens. You can assign that texture data from the view model to a custom UI material. Here we're doing just that and applying a cool green color and a scanline effect via a material, a UI material. This is that widget that we saw earlier over here, right? You can see the source texture art in the top left corner over here. And this pink arrow over here is the parameter that we're passing to the material assigned to the image here. So we're passing this texture to the texture parameter of the material, and this is the binding for it. So the result is that the material just processes that and looks like that. Similarly, you can pass data as scalar parameters to a UI material. This is really useful for HUD design. It lets you make progress bars for things like player health. Here, just to add a little flavor, we're making the player's portrait bounce faster as they take more damage. So just like the other example, I'm passing data to a material parameter. In this case, it's called bouncing speed. And the value I'm passing to it from the view model here is health. It's a floating point number. And the result is that player over here, portrait, will bounce faster or slower based on that number. This one's a real workhorse. It helps with the usability of your HUD, and it can make your HUD look great. All right, next I want to go over another useful binding technique that lets you generate a stack of widgets from an array in the view model. All right, let's say we've made this widget over here using all the techniques that I just really quickly covered. So we have our view model on the left, our widget in the middle, and say our data bindings are on the right. And so that's just, again, player health, shields, and portrait on the right. All right, and suppose our goal is to make a HUD that looks kind of like this, where all your players on your team, including yourself, are shown in a vertical stack on the right. The first step is to make a new widget. It's just like a root empty widget. All it needs to do is house the array of our widgets. So literally it just needs to have a stack box in it, for example. Any panel, really. We're using a stack box here. The next step is to add an array of player info view models. So that's what's happening on the left. We're picking the player information view model, and it has this array of your team. And finally, we need to add the view model extension to the stack widget. So this is our root widget. Here's our stack box, and we're going to add this view model extension by clicking that button. You can see a video here. Finally, we add that, and once you do that, you simply choose the widget that you want to appear in here, and then you choose the view model that's in that widget. And once you do that, you can adjust the layout properties such as padding and alignment, and you can even choose how many you want to preview in the editor here. Here, I just want a stack box, vertically stacked, which is pretty cool. So now the binding for this is a little more complicated than the others I just shown. You have to choose the set items from the view model extension that was added, and then you bind it to the array from the view model. Let me zoom in a little bit on this. So here's a slightly closer look at the bindings. So here is the set items on my widget from that view model extension we added to the stack box. And here's the array in the view model that we're passing to it. And the result is that it just creates as many items as there are in that array. So this is a really cool way to make a really bespoke team-based HUD, for example. All right, I know that's a lot, so let's get back to Ballistic. And I'll show you how we set up the player health widget. Okay, so here's how we set up that simple white health bar in the middle of the screen over here. First, we pass the health value from the view model to the material using the technique that we just went over a second ago, or a few minutes ago. And then we do the same with the max health value. So this sets up the health bar. We do this in this case because the max value of health can change. So we're passing it that material was built to intake the max value as well. Then for that big text block, we simply bind to the conversion going from number to text, and that's what puts it up here. And we would do much the same for shields. Lastly, let's talk UI animation. So you can make animations using the sequencer tool in UEFN, in UMG and UEFN. And here's how you can trigger them. So first you add a conditional binding by clicking on the Add Condition button. It's there in pink arrow. Then you configure it to evaluate your view model data. When it evaluates to true, you can tell it to play your custom animation. You can also tell it to reset or stop an animation in the same way. So here we set it up to play an animation that we named Anim Low Health when the health value is less than 20. All right, and here's a low health animation from Ballistic. You can see the sequencer animation tool at the bottom running. As you can see, it's actually pretty fancy, pretty intricate. It was made by a talented artist, and it was made using custom UI materials. At the bottom, you can see how we're actually animating material properties, those same types of properties that we were talking about during this presentation. So UI materials indeed do a lot of the heavy lifting, and they can be quite complicated. There are specialists who work just on this. That's a pretty intimidating picture. To help in this area, we're making a few handy UI materials available to everyone. So these materials give you a lot of out-of-the-box capabilities to make a diverse array of useful HUD UI, such as bar meters, radial meters, textures, a lot of meters, and visual effects that you can apply to things like the player's portrait and the item in your hand. A 2D picture of the item in your hand. So here's how easy it is to design your own progress bar, for example. We take a Pepto-Bismol color, and here's a meter. We're adding a thickness to a border, adding some rounded edges. We're going to round the meter on the inside, add some slant, and there you go. So, pretty straightforward. And all these progress bars were made from the same material. So obviously they all look different, but notice some have a bright edge to better highlight their position. And notice how some of the gradients can be used to create zones, and some even have like 3D effects. Not gonna lie, I spent way too much time making cool meters for this presentation. I'm not even kidding. Similarly, here's a bunch of radial meters on the left. Again, a lot of diversity from just one material. This is a separate material than we just saw. This is the radial material. But yeah, I had fun. These are textures, the texture meter. These are all textures with very custom shapes, and they're simply PNGs that we exported from any design tool and converted to an SDF shape. This is stuff you can learn about in documentation, but it's very straightforward actually. Here's some segmented meters. These are very cool. Notice how the wood meter, the wood piles in the bottom are being filled continuously, while like the hearts and the triangular shapes are being filled discretely. So that's just a parameter in the material. Lastly, here's some of the things that you can do with the texture materials. On the top, we are animating the player portrait out of hexagonal shape. That shape could be a circle or a square or a custom shape. And notice how we set it up to pop through the shape at the top. That's the texture mask effect, which is pretty handy. And the bottom is looping through a bunch of different visual effects that can be difficult to do in materials. Okay, and these materials are available to everyone. Okay, so as a reminder, the default HUD looks like this. And here's some examples of what you can do. All right, so here we have a player portrait popping through a shape, and we have the health and shields bar as textures. And notice as the shield goes down, it'll start to blink red. That's built into the material. So this immediately, I think, just gives this experience a feel, a certain feel, right? Very different from what out of the box you get in Fortnite. We're gonna go through a bunch of these. I had fun. Here's a radial meter where your health is radials, and as you take damage, we're showing that delta value as text popping in, and you see the colors animating and the guy's head's bouncing. This is all through the same techniques that we went through. I'm just killing this guy over and over and over again. So here's a very different take. This is your shields is like these tick marks in a radial. And once the shields go down, you'll notice that damage comes in as health, as red from the outside in on the shape. Here's those player cards from before. The cool thing here is that you can see your teammates have little tiny cards on the left, and your card can be big. You know, this has a really different shape. This would feel really good with a top-down camera, maybe, I think, a game like that. This is a really cool one. I want to pause it. So actually, I'm okay. So notice that as you take damage, it's highlighting the area, like in a fighting game. This is a really good technique to improve usability so the player can really see the damage that they're taking and it can be highlighted. This is made possible with the delta information in the player information view model. Here's another very different take. This one looks great with like 8 or 10 players in the bottom even. It's like a brawler style. Here's another take on that, just very visually different, a bit more whimsical. This was my favorites. This is like almost like a 1v1. And notice the sort of bright edge on the health bar. I paused it here. That's another, that's a setting in the parameter, and it's very useful for making it easier to see the edge of the health bar, improve usability. Okay, so let's revisit the village project example with some custom UI. All right, so here we have a player portrait with hearts and shields. And you see the materials that we're using called out on the screen there. These are the bindings for the heart, for the health, and the shields. The same pattern from before. And you can notice that there's Animations happening. There's 3 animations set up: when you lose shields, when shields go away, and the hearts bounce as you take damage. It's fun to see a different camera perspective here. Another fresh take on it, this is with radials for health and shields. The health is a discrete segments, and the shields is continuous. And notice the animations on each as we continue to cook the player in the fire pit. All right, and this last one from Village. Oh. There we go. This is slightly different. Here we have your health and segments. And the cool part here is that you can see, again, the damage coming in as text and kind of floating up off the screen, which is kind of a fun feel, I think. All right, so we're going to wrap up this portion with revisiting the Forest Guardian demo, which was one of my personal favorites. All right, so here we have some fresh UI for a Forest Guardian, maybe to fit the world better. We have our player information view model in the top left. We have a new widget with just health and shields. And we have the data bindings on the right. And we also added the equipped item view model. So we're showing the item in hand in that circular orb on the far left. We have a mask equipped right now on the bottom of the HUD. And there's a bow and arrow. Okay, so now we're running through this world. I think it really elevates the game to have UI to match the experience. We're going to grab this sword. And we're going to go and run into some spikes. Because why not? As you take damage, you'll see your shields will have a very subtle animation, which is nice. It just gets brighter and pulses a little bit. All right, next we're going to look at the health bar animation. So I wanted to call attention to how this was set up a little bit. Here we're simply, what we're doing is we're animating through a conditional animation. We're making the health bar material turn red at different gradient points. So it's all through data bindings and the animator. So I'm going to block a few hits here. And then notice the health bar will turn red as I get hit. And it's game over for me. All right, before I hand it off to Jay to talk about best practices, I wanted to share that we'll be updating the UI feature example in UEFN with the materials that we shared here. We'll show this QR code again, which takes you to that page. Thank you.
All right, thank you, Derek. Okay, this is going to be a speed run of game design best practices and how UEFN supports you. For experienced developers, I want to demonstrate some ways that UEFN supports the game development practices you're familiar with. For creators new to UEFN, I want to show you some tips and tricks and good guidelines to keep in mind when developing your games. Let's start with tutorialization and onboarding your players into your game. We'll employ some of the UI capabilities we just learned about and talk about your first-time user experience. Onboarding players. This can make or break your game. Seasoned designers know a few rules. First is that you should always get to the fun first. Often used adage is you have 5 seconds to get to the fun. Another is dispense information slowly. I see some UEFN islands that do this, and I want to show you that you have more options now. Third is let your players know what their short-term goal is up front. Instead of bombarding with information, give them what they need to do first, and then deal with the long-term goals later. If you start here, you can let your player focus on the fun. Here's an example of a short-term goal. Be creative. The player approaches the sword. I tell him to take the blade, banish the darkness. The player gets the sword and knows what to do, and they jump right into the fun. How do I set up what I just showed you? The steps involved to do this on a high level are to build the UI widget, as Derek just described, and to use the HUD message device to pop up that message. We call that a toast because it pops up like a piece of toast. But we don't want to show that logic to the player every single time they play, perhaps the first time. So we need to write logic to show that prompt once. I'll show you what verse you have to write to make that happen. First, you have to create your class that will store the data you want to save for your player. In this case, we're defining whether we've shown that short-term toast. Player profile data class is the class we create to store that data. You'll see it has a final specifier on it. That means it cannot be inherited from or overridden. It's also marked as persistable. This allows us to store it in a weak map to persist across game sessions. Second is you need to set up a constructor for your data class. You'll use this to make partial updates to your data when you want to modify members and update player save data. Third is where you actually store the data. You want to create a global weak map variable. This weak map is what maps this data class you just created to the player. Each player is the key. So when they join the game, you will use the player themselves as the key to retrieve their data. So player and then data class. To ensure you show them the UI element once, first, call a function you're going to have to write to check to see if the player even has data. This is good practice. If they don't have data, you want to initialize it. Then we want to check the save data for the player. Then we check our logical Boolean. Should we show this toast? Is it true? If so, then we call show on the HUD message device. That'll pop up that toast. Then save that you have showed them this information. So that function is something you write. How do you save it? Here's how we save that data. Check if the player has existing data. If not, initialize. Get the existing data out of the player profile so we can use it in the constructor. We will now set the field we want to update, show short-term toast. You start by setting the data in the weak map. You can assign it. You call the constructor using your player profile data. And then you change the value that you want to update. And this is how you do a partial update of the class. So next time we check, should we show this UI element? We're not going to because we've set that flag to false. They've seen it already. So let's talk about feeding player tips. You want to give your player little bits of information as they play. You want to try to space these out as to not overwhelm them with notifications. And you should find the right context, right time to do it. If their attention is locked in combat, for example, that's probably not a great time to give them a tip on how to defeat the boss because they're focused on surviving and fighting. Here's a scene that's calm, for example. The player's on the path, and we give them some hint on how to progress. And I'll leave it on screen for a while. Prove yourself to the guards. Okay, that's a goal that I can follow through on. I know what to do next. Let's talk about version updates now. Games on Fortnite are ever evolving. You update your game with new content, bug fixes, maybe a special event, and you want to tell your players. And you want them to confirm that they've seen this because it's really important to you. This is where you use the pop-up dialog device. The pop-up dialog device handles the UI and logic display for you. And the difference between the HUD message I just showed you And the pop-up dialog device is the pop-up dialog device lets you use a button so the player can confirm. It looks like this. Upon login, you can welcome the player to your new summer update and tell them that there's new vendors, that the dungeon level 10 is now open, you have fixed some bugs with that wolf boss fight, and the beach event has begun. Now let's talk about second first times. How many of you ever played a game where you walk away for a really long time and you come back to it and you have no idea what's going on? See a lot of nodding heads, yes. If a player lapses in your game and wants to come back, help them get back into it. You can actually save the last time a player logged in using a verse function in the verse digest called getSeconds since epoch. Go ahead and go look it up. But you can create a data field in your profile data for the last time they logged in. And when they joined the game, you can check that last time. If they haven't logged in a long time, you can prompt the player and perhaps ask them, hey, would you like to reset the tutorials and see them again? All you'd have to do at that point is reset all their player profile data that you used to trigger the tutorials. Here's an example. We prompt the player. Warrior, it's been a while since you last played. Would you like to enable tutorials as a refresher? The pop-up dialog can have more than one button, and you can use it to give the player the choice. If they say yes, then you would just respond by resetting all the tutorial data. And if they say no, you just close the device. They understand what they're doing. They got it. Let's touch on progression and persistence and how to keep your players invested and coming back to your games for more. Islands are creating economies for their gameplay. They keep track of stats, accomplishment, currencies, player preferences. By using persistable data in verse, you can track and save data per player between play sessions. This opens up a variety of progressional game modes where players can leave and then come back and resume their objectives or find their game as they last left it. You can add things like the player's level, as I demonstrate here, or enable the saving of players' choices, such as a faction that they joined or any customization that the player can do. Perhaps like a progression path where they choose which they choose in a tycoon game. If you can encode it in a class, you can persist it. The pattern is the same that we used in tutorialization. You add the data you want to your player profile class, player level in this case. You create the constructor, add it to the constructor if you already have one, and ensure that you've already created your global weak map variable if you haven't. And you have to handle it in 3 parts. When the player joins, you load the data, then use the data, and then set the data when you want to update it. So on join, we check if the data exists. We get the current player level so you can use it in gameplay. Then you can call any updating you have to do, like say updating the UI. So your player is playing and they level up. You need to save that. You validate that we have saved data. You call set on your weak data map. Call the constructor using our player profile data and do that and update the value for your player's level. Hope you're seeing a pattern here. It's the same pattern over and over, and it's that easy just to save data persistently for your player. Progression in all forms is very satisfying and keeps your players invested in your games and keeps them coming back. So leverage it. Okay, let's talk about the things you have at your disposal in UEFN to prototype your games. Prototyping. When you begin your game, I implore you to start with gray box. Build out your worlds and spaces with just basic shapes. This enables you to focus on core gameplay. What does the player do in your world? It's efficient because when you make changes to the gray box, it's very easy and minimal, and you're not throwing away very much work. You can, in gray box, identify potential issues such as occlusion, spacing, line of sight, travel time. You also don't have to burden your artists with changing polished assets, and it saves you a lot of time. During the gray box phase, you can also not overcommit to an aesthetic. Is this a underground cavern or a post-apocalyptic wasteland? You don't have to decide at that point. You can just focus on the gameplay. Another benefit is if you're using AI, you can check on combat with the AI and their pathing and navigation before you add custom assets. If it works in the gray box, then you know that the only change when you add custom assets is the custom assets, so you just can double check those. You already have your gameplay tuned. You know what you want. So let's go over some tools to help you do this. Modeling mode. You can find this in UEFN, and modeling mode enables you to create and sculpt. It allows you to create custom props. You can edit meshes, shapes, attributes, tweak level of detail, edit UVs. You can use the modeling mode to create shipping quality assets if you'd like. However, for the purposes here, it's an excellent prototyping tool. Modeling tools come with several shapes to start with. They include commonly used shapes for prototyping, and there are parameters for these shapes so you can quickly change elements such as the width of these stairs, the height, the depth. I recommend exploring the tools and its documentation. Next in prototyping, gray box assets. So let's say you don't want to use the modeling tools. We ship UEFN with a lot of gray box assets. They're found inside of Fortnite gray box. They're included in every UEFN project. The important thing to note is that these are scaled for the Fortnite character. So you have the crouch height, the full height. They're also an excellent place to start building your game. I want to point out Live Edit here on this slide, and I'd like to demonstrate that. Assets in Graybox work with Live Edit. As you work in the editor, they update immediately in the client. This enables you to iterate very quickly. This one's fun. Cube Grid is a feature found in the modeling tools mode. It's a mode of creation by pushing and pulling mesh on a cubed grid. It uses keyboard shortcuts, which I know many of you level designers love. I just want to demonstrate it. You specify a grid area, and you pull to create volumes. You then push to subtract. This enables you to create doorways, openings, walkways, walls. You can even manipulate edges and corners. It's honestly a lot of fun and really fast just to try things out. Then, when you're done, you can fix your mistakes along the way, mark it as done, and then populate devices, spawn pads, push your changes, and test them. Collision and navigation just work out of the box. You can iterate on your spaces quickly and finalize them before you commit to more permanent art. As you prototype, you want to be sure you can set the tone and mood of your environment before you add final assets. Traditionally, this takes a lot of work, but I want to point out that you have the day sequence device at your disposal. You can use it to tune time of day, change the cycle of your day, or pause it entirely. Add fog, modify the sky, clouds, sun, moon, and you can change the colors of all of those elements. I combined all these to create a moonlit night where it's foggy. I highlight the door with the light. Indoors, I remove the fog. And I've created a different feel from the base project level. So in that final result, I used Graybox assets and modeling modes to quickly create a space. I leveraged devices to accelerate my prototyping. I iterated using built-in content for quick turnaround times. And then I went to test. So speaking of testing, you're building your game. It's in a playable state. You run directly into production, right? No, you want to playtest. Let's talk about playtesting your game. Your game is likely multiplayer. You've written verse code to handle all your multiplayer logic. I need to highlight that UEFN has a new feature called test players. Prior to test players, you needed multiple accounts and multiple devices to log in order to test your multiplayer verse code. Test players are stand-ins for players. They can be damaged, assigned to teams, They can spawn on player spawn pads and even instigate devices. You can turn them on under the debug menu in the island settings. This is the prop hunt template you can find in UEFN. One team plays disguising themselves as props in the environment, hiding from the other team, who must hunt them down and eliminate them. Using test players, you can test your start game logic and game logic itself. The heartbeat mechanic is written to give away players a hide in the space for too long. This works on test players. Here I'm demonstrating that they can be damaged and eliminated as a hunter. All test players function as stand-ins for players, so I can test all of this logic. And the best part is you don't need multiple accounts to test. You can do it all yourself. A bit of verse for test players. Get players function returns an array of player agents. In that demo I showed you, if I called that function, it would return just me because I was the only one in the game. You will need to use get participants, which returns players and test players as an array of agents combined. If you find that you absolutely must know if it's a player, say to update the UI, you'll want to iterate all your participants and just cast them to be a player. If this statement succeeds that I've highlighted here, then you know that it's a player. Okay, playtesting. Successful developers playtest their games with real people during development. You should play your own game often, but nothing beats real player feedback. UEFN has the capability to publish a private code, island code. These are used by your development team to play test in Fortnite as a player would. UEFN also allows you to publish play test island codes for people not on your development team. In Creator Portal, you can create playtest groups. These are a list of players that you want in your playtest. You give them this private playtest code. No one outside this list can use this code, so you don't have to worry about it leaking. You create your list, you create the code, and you hand it out and set up your playtest. Setting it up is so quick and easy. With this workflow, you can actually be running your playtest, realize that something's wrong, or want to try something new immediately. And while your playtest is running, you can open UEFN, make that change, and publish a new code, and just hand them out to those players, and they will play your updated island. Some quick guidelines for running your playtests. Playtest early. Set up your playtest so that you can observe your players. Please watch them play. If you can't observe them directly, make them record their session and give it to you later. You will learn a great deal by just watching where they spend their time. What do they look at? What do they get frustrated? What do they get stuck on? There's an excellent talk that expands upon this more. I recommend, if you're interested, please go take a look, called Playtesting Do's and Don'ts by Bradley Reeb. It was at Unreal Fest 2023. Check it out. Lastly, Fortnite can be found on many platforms. UEFN helps you publish to those platforms. They all have different graphic settings and capabilities. The UEFN editor has a feature called Preview Platform. That enables you to preview what your game looks like on various devices in some settings. It lets you view things like level of detail and lighting modes, whether shadows are on. And you can preview for consoles, mobile devices, and in the PC setting, performance mode. You should test performance mode because many competitive players use performance mode to maximize their frame rate above all else. So you should double check that your game looks good in performance mode. While there's no substitute for actually testing on all devices, this can help you iterate quickly to make sure you resolve issues for a specific platform or configuration. Here's what it looks like. In the upper right of the editor, under Settings, you'll find Preview Platform. First, I tried testing on a mid-range mobile phone. And that's what it looks like. I'll then switch to, say, a portable console. And I accelerate a little bit here, but after some time, you'll see a little more detail, more shadows. Then I switch to PC performance mode to show what that looks like. and I can at least make passes on my island to ensure it looks and works the way I expect to on various devices. So, in summary, tutorialize your players. Leverage some of the things you learned today to do that. Use persistence to keep your players invested in your games and coming back for more. Prototype your game to prove out your ideas before you go into production and leverage the tools that UEFN has available for you. And use test codes to play test early and play test often. Thank you for your time, and we'll now be taking your questions.